So here we are in the garage, and we have a total of 32 batteries. From your perspective, you'll see about 8 of them on the first bank. There are 4 banks or groups of batteries here. It's necessary to have a minimum of 8. This is the inverter, and the inverter requires 48 volts input. So to get that from 6-volt batteries, each one of these batteries is 6 volt, so we need to put them in series. So we have 8 batteries in a group in series, and that gives us 48 volts. 6 times 8 is 48. So we have 48 volts that comes off of this battery group. There are 4 groups here. In the distribution panel, the battery groups are come in to this distribution panel, and each group has its own breaker. Each one is 80 amps. That in turn goes to the main DC cutoff. This is where all the DC comes to, including the power from the photovoltaics. Comes in through this conduit here, goes through the charge controller. Remember that I said that the photovoltaic panels, the solar panels, produce, I have them grouped in such a way that they produce 70 volts and 50 amps. That's where this is going to come to. But our inverter only likes 48 volts. It can only deal with 48 volts. And also, mind you, that 70 volts will vary depending on how much sunlight it gets. So what this box right here does, this is the controller. And what the controller does is it takes that 70 volts and converts it to exactly 48 volts. And then once it converts it to the 48 volts, then it comes into the distribution panel and ties in to the main bus here. This is the main DC bus right here. I have all of the DC turned off at this time. If I wanted to, I could turn this on. Actually, the batteries are not hooked up, but the PVs are, and I don't want to activate this just yet. But all I'd have to do is turn this breaker on here, and the power from the photovoltaics would be coming through the distribution panel into these large cables here that tie into the inverter here and here. This is the inverter. The purpose of the inverter is to take the DC, the direct current, the voltage from the direct current sources, again from the photovoltaic panels that are behind, about 100 feet up on the bluff behind us. And we're going to take that and take this DC power, a lower voltage, 70 volts, and actually convert that 70 into 48. Then from 48 volts DC, it's going to go into the inverter, and the purpose in the inverter is to take that DC and convert it into AC. And AC is what we have in our house. So it's going to convert it into AC, alternating current, and we're going to produce it at 6,000 watts. This is a 6,000 watt inverter. This is a Xantrex 60XW6048, and what those numbers mean is that it's a 6,000 watt inverter, and it runs on 48 volts. So it takes 48 volts DC in, and then produces 60 amps and 110 volts, and those come up into these breakers here. From here, this power goes into the house, and it's redirected. It goes out through the bottom and goes through this conduit here and goes into the house next door.